Hello everyone, a very good morning. This is Akriti and today I am here to solve a daily problem of Leetcode. So let's start with the problem. This is the question number 995, minimum number of k consecutive with flip, right? So in the question we are given a binary array nums and an integer k, right? So what actually k bit flip mean, right? So here in k bit flip we just have to choose a subarray of length k from the nums which we are already given, and simultaneously we have to change, or you can say flip every weight of this particular subarray, right? So basically if a particular bit of a subarray is 0, then you have to change it to 1 and vice versa, right? So we have to return the minimum number of k bit flips, or you can say the minimum number of operation which we are going to perform, which will be required to make a nums array such that there shouldn't be any zero left in the subarray, right? So basically you are given a nums which is your array, and in one operation you can choose a subarray of size k, and you can flip all the bits or all the numbers in the subarray, right? So you have to make sure that all the numbers in my nums should be 1 in the end, and you have to perform as minimum operation as you can, right? So yeah, let us suppose this is my nums, and the size of the subarray is k, which is 1, right? So in one operation I can choose any one element from my array and I can flip it, right? So let us say this is my element. Now as this element is already 0, then we need to flip it to make it 1, right? Because in the end we want all the element to be 1, right? So we will be flipping this element and this will be our one operation. Now when I come to this element, this is already 1, so I need not to perform any operation here. I will move to the next element, and here again this is 0, so I will be performing one more operation to make it 1, and this way we will be able to make all the element of my nums equal to 1 in just two operation, or you can say 2 k bit flip, right? So let us call a k bit flip our operation. Okay, so in the second example you can see, now we have to make a subarray, or we have to choose a subarray of size k. We cannot choose any element, like you cannot choose just a single element and flip it. No, you will have to choose a subarray of size 2, and you have to flip all the bits which are there in your subarray. So let's say I'm here at this particular subarray, right? Now as all the element of this particular subarray of size 2 are already 1, right? So why will we be performing any operation here? So I will simply move to the next subarray, which is this one. Now in this subarray you have 1 0 and 1 1, right? So to make this particular 0 as equal to 1, you will have to perform operations here, right? Because otherwise you will not be able to convert this 0 into 1. So I will be performing an operation here, and once I perform the operation, my this 1 will become 0 and this 0 will become 1, and now I don't have any such subarray such that I can make this 0 equal to 1, right? Because any number of operation you perform, you will not be able to convert this nums into a array of all ones, right? So here we are returning -1 because we were not able to convert my nums into array of 1, right? So no matter how many flips we make, it is not possible at all. Now let's come to this example. We will be understanding this example here, right? So this is an example, and here k was 3. So basically we need a subarray of size 3, right? Now let's observe one thing. Suppose this is our nums as mentioned in the example. Now if you want to flip this 0 into 1, right? Because this is necessary, because at the end we want all the zeros to be 1, right? Now if you want to convert this 0 into 1, definitely you will have to choose this particular subarray, because you don't have any choice in the left itself, right? So you will have to choose this subarray only. So that's why we are starting from the leftmost element, and we will just try to make sure that I am performing operation for the leftmost element to convert it into 1 if it is 0, right? Because for the leftmost element, we don't have any choice except for 1, right? One subarray. So as you can see, for this 0, you can only convert it into 1 by performing operation in this subarray, right? Because once you move to this or this or this first zero is not going to affect at all. So I will have to choose this summary only. So we are starting from the leftmost element, and now I am only concerned about this, which is my I equals 0, right? So now I am only concerned about I equals 0, and I'm just going to convert my 0 which is placed at I equals 0 into 1, right? And firstly I will have to check if it is already 1. Like if it is already 1, then I will simply shift my summary because I don't want to make any operations here. But initially here it is 0, so I will be performing an operation, right? So simply I will convert all the element of this particular summary into 1, right? So let us do this. So as my summary was this, so I will be converting all the element into 1 here, right? So yeah, basically I am done with this summary, or basically you can say I'm done with the 0th element of my number. Now once I'm done, I will increase my number of operations. So let us say my number of operation being 1, because we have already performed an operation. And now I will shift my window, right? Now as I have shifted my window, now I am concerned about the first element of the window, or you can say the I equal 1, right? Now I only care about I equal 1. Now I will check if I equal 1 is equal to 1, or it is equal to 0, right? Because if it is already equal to 1, then I need not to perform any operation in this summary, because we are just already done with the left part, right? Because in this left part I have already converted all the zeros into 1. Now I am only concerned about the right part, right? Now if I'm standing at a particular index and its left part is already shorted, and the current element is also equal to 1, then why will I perform any operation here, right? So I will simply shift my window. Now here as I have shifted my window, I am at I equal to, right? Now I will just be checking if the element at the I equal to is equal to 1 or it is equal to 0, right? So here also you can see it is equal to 1. So simply I will shift my window again. Now I have this summary where these three elements are there. Again the first element of the window or the summary is already equal to 1, right? So I will simply shift my window, right? Now once I am here, I can see in this particular window or the summary, the first element is 0, right? So here I will have to perform operation, because if my left part is already shorted and this particular element is 0, then this can be the only window or the only summary which will be performing operation for converting this 0 into 1, right? So in this window only we will have to perform operation. So let me just perform the operation here. So as I am performing operation, so I will be flipping all the element of this window. So I have flipped it, right? So this was a window, right? So as I have already converted or performed the operation, I will just increase my number of operation by 2, and now I will shift my window again. Now here you can see the first element of the window is equal to 0, right? Then again I will have to perform operation because it is equal to 0. So let's perform the operation here. um, I will be converting this 0 into 1, and this, yeah. So we are done. Now we cannot find any more summary by shifting my window, because you will have a summary of size 2 only, but the required size of the summary is 3, right? We cannot have a summary less than whose size is less than 3 or something. So now we cannot make any summary, or we cannot perform any operations. So the last summary was this. Now the last operation you performed on this element. So before going further, you will have to check if the remaining element are equal to 1 or not, because we are not left with any summary now, right? Because if you do not have any summary further, so you cannot perform operation for these elements, right? Or you cannot check for these elements. So you will have to make sure they are equal to 1, because like suppose let's say this was the condition, right? So when I was at this point, this was my summary and I was performing operation for this element. Now let us suppose if there was 1, right? So if there was 1 and I am at this particular index, so I can see the element which is there in this index is equal to 0, right? So I will be performing operation for sure. So simply I will perform operation and I will flip all the bits in this array, and once I flip my bit, this will become 0 and this will become 1. Now as this was my last array, I cannot perform operation anymore, right? Because I am not left with any subarray. So once I'll check the remaining element, which is after this particular element. So here you can see these two elements, I am having 1 0, right? So here you are not able to convert all the 1 into 0. So here in this case I will be returning -1. That's why I was telling you to check the remaining elements, right? So this is something what we are going to do now. Just let's observe one thing. um while performing the operation, or while just convert flipping all the bits of your summary, what actually you are doing in context of bit manipulation, right? Just think in case of bit, if you have a bits and you are performing an operation on a particular summary, right? So here as we have seen in this summary, if I was talking about this summary, I am just only flipping all the bits of a particular uh, summary, right? Now let's suppose this is my summary, right? If I want to perform operation, I will simply flip the bits of this summary. Now what if I tell you, why don't you just perform the XOR operation with a mask of size k? Here k was equal to 3, right? So let us say this is my mask of size k. Right. So suppose I have a mask of size k, and if I am at this particular Savari, I will simply perform XOR operation with my mask and the element of the Savari. So what I will get, if I will perform XOR operation of 1 and 1 XOR 1 is going to be 0, 0 XOR 1 is going to be 1, and this is also going to be 0, right? So basically it is simply flipping my bits, right? Because 1 is becoming 0, 0 is becoming 1, and 1 is also becoming 0. So simply here you can see, by performing the XOR operation with my mask having all ones, we are simply getting our bits flipped, right? So this is something we can do with the help of bit manipulation. Instead of just coming to a summary and just converting or flipping each bit one by one, it is going to take so much of your time. That's why I will be solving this with the help of bit manipulation. And just this operation of flipping all the bits of a summary is just equal to performing XOR operation with your mask, right? So this is something we are doing here. Now let us say this is your mask. So how will you create your mask? Simply initially we were starting from the first summary, right? So my mask will be this, and all the elements of the mask is, let's say, it is 0, right? So I will set my mask as the initial configuration is this. Now as just because initially this is my summary, so I have put all the ones in the first three element of my mask, and once I'm done with this summary, I will simply shift it to the next three element, and I will perform XOR operation, and again I will shift my mask. So basically just we are um shifting my mask by one, and we are performing the XOR operation, or you can see we were just flipping all the bits of the summary if needed, and we are shifting our mask. So this is something we are going to do. So instead of just considering each element of the summary and flipping bit one by one, we are going with the help of bit manipulation. So first of all, let us convert my given array nums into a bit set, because we are going to do this question with the help of bit set. So yeah, now here in the constraint you can see the maximum size of nums can be equal to 10 to the power 5. That's why my bit set size is also going to be equal to 10 to the power 5, right? So let us suppose n be the size of the array which we are given here. Let's convert it into array. Right, so n is the size of my summary. Now I will be making two bit set. One is my actual array which we have here, which is bit set of size 10 to the power 5, right? So let me make it equal to 10 to the power 5. Yeah, so this one is my big summary, or you can see the actual array we were having here. So let us say this is the big array or the actual array we have, and this is my mask, right? So we have just we have just made two bit set. Now for converting the first bit set, which is big equal to my array, like if I'm having a element 1 at a particular position in my array, then the corresponding element in the bit set should also be equal to 1, right? So I'm simply just converting my bit set into the array. So let's start from the first element till the last element, and I will just check if my element at the ith index is equal to 1, then I will simply set my bit, right, of the big bit set. So here I am setting my bit, sorry, at a particular index, right? Now, same I will be doing for the mask. Now, initially, as I have told you, my mask will be for the first k element, my mask will having all the bits equal to 1, and for the remaining element, my mask will be having all the bits equal to 0 initially, and then we will keep on shifting it, right? So, for the first k element, I equal 0, and until I equal k, my mask will be having all the bit equal to 1. So, I will just set all the bits, right? This is something what we have done initially. Now I will start from the first element. So this is going to be my first summary, and my summary will go until n minus k, right? Because as here also you can say this was the last summary. So this was the last element which we were taking into consideration, right? Because after this element we cannot have any summary. So this is the last element which is equal to n minus k. So I will go till n minus k and I will increase my I one by one. Now, if you are at a particular element, what we were doing, we were simply checking if it is equal to 1 or not, right? Because here also, if you are at a particular this element, you will check if it is equal to 1 or if it is equal to 0. And if and only if it was equal to 0, then only we were performing operation. Otherwise, we will just move into the next summary. So here we will check if the bit at a particular position or the corresponding index is equal to 1 or not. Now this is a test function which is used in bit set to check if a bit is set or not, right? So if it will return 1 if the bit is set at a ith index, and if it is unset it will return 0, right? So I am just checking if it is unset, only then I will be performing my XOR operation with the mask. So here my original array is going to be original array XOR mask, right? And I will increase my number of operation. Now if I am not if my corresponding element is 1 or 0, I don't mind, I will simply shift my mask, right? So here I am just shifting my mask by 1. This is equal to left shift by 1, right? So this is something I have done. Now as I have told you, once you reach the last element which is having the last summary, right? Because you cannot have any summary after this element. So I have told you we had to make sure the remaining element are equal to 1 or not, because if you are at this index you cannot perform any more operation now. So you will have to check for the remaining element, because only if they are 1 then you will be returning the number of operation, and if any of the remaining element is equal to 0 you will be returning minus 1, because then it is not possible for you to convert all the element into 1, right? So I will check from the last element where we left, which was n minus k itself, right? So till n I have to check if they are equal to 1 or not, right? So if my bit is not set at a particular index, so here I will be returning minus 1 in this case, because any element after the last summary we had, or you can say in the last summary we had, if any element is found equal to 0 then we will be returning minus 1. Otherwise we will be returning the answer which we got as the minimum number of operations we could perform. So this was the whole solution. Just let me check if it is working. Oh, I need to initialize my answer as well. So let us suppose let answer be 0 for initial. Okay, fine. So it's working now. Yeah, guys, it's working. So this was the whole solution and the approach which I have told you for this question. Now, if you have any doubt, you can ask in comment box. I'll try to resolve them. Before moving on, let me just summarize what I have done. So basically, we were given an array and we have to choose a subarray of size k, and we have to flip all the element which are there in that particular subarray, and this will be our one operation, and we have to make sure we are just converting our array into array of all ones with the minimum possible operation we can perform, right? So in one operation, what we were actually doing, we were just flipping all the bits. So I said, what tell me an operation of bit manipulation which is equivalent to this operation which we are performing here. So here I observed that it is equal to XOR of the current subarray with a subarray of all ones, right? So here I have just considered a mask which was having all one for a particular subarray, and I was just performing XOR, and once we perform the XOR, we will simply gather all the bit flipped of that particular subarray, right? So we were simply using that mask, and we will keep on shifting the mask one by one for each subarray, and we were checking the number of operation we have performed. Now once you are at a last subarray, you will check for the remaining element of this subarray if they are equal to 1 or not, and if they are not equal to 1 or any element is found equal to 0, then we will be returning -1, because then it will not be possible for us to convert all the element of the array equal to 1, right? So this is something which we have done with the help of sliding window and bit manipulation. If you have any doubt, you can ask in comment box. I will be providing you the solution of the problem in the description box, so please check it out also. And I hope you understand the problem. So thank you so much for watching. Have a good day.